Okay, in this video, I want to talk about partial fraction. Now, a partial fraction is a method, and use this method, we can rewrite a rational expression into a sum of a couple of fractions. Now, how this method is useful when we are finding integral. So, for example, if I give you this integral, if I give you this integral and ask you to find it, this is so difficult, right? But what if I told you we can rewrite this rational expression 4x plus 18 over x squared plus 4x minus 21. We can rewrite this into 3 over x minus 3 plus 1 over x plus 7. So therefore, this integral becomes the integral of 1 over x plus 7. So now, to find the integral becomes very easy, right? Because for each integral, we use substitution. Like here, we let u be x minus 3, and here we let u be x plus 7, and then we use this formula. So we can find the integral, right? We can find the answer. Now this is the advantage of using this technique when we are finding the integral. So now I'm gonna show you this method. Okay, we're gonna discuss this method in two situations. The first one is if when this function or when this rational expression is proper. Is proper means proper means the degree of the numerator is less than the degree of the denominator. And then after this, we will look at the second type, when the degree of the numerator is greater than the degree of the denominator. So like in this example, this is a type 1, right? Because the degree of the numerator is 1 and the degree of the denominator is 2. Okay. So over here, our px is x minus 8, and our qx is x squared minus x minus 2. After we determine the px and qx, now we think about how can we factor this expression x squared minus x minus 2. Now in college algebra, we learned how to factor this trinomial, right? So we can factor this into x plus 1 times x minus 2. So each factor is a linear factor. It's called a linear factor. Why? Because for each factor, the degree is 1, right? So now we have these two linear factors. So therefore, we write this rational expression into x minus 8 over x plus 1 times x minus 2. And we let this be a. Now a stands for some number over x plus 1 plus b over x minus 2. Now here a and b, they are two real numbers. And then we solve for AB. Because if we can figure out what are A and B, then we can rewrite this rational expression into the sum of these two fractions, right? Now, how can we figure out AB? So this will require you to solve a rational equation. Now, I will show you how to do this. So if I want to add these two fractions, right? I need to, at this point I cannot do this because they have a different denominator, right? So I need to find a common denominator, or least common denominator. And for this case, the least common denominator is a product of these two factors, which is x plus 1 times x minus 2. So therefore, the first denominator, it needs a factor of x minus 2. So I multiply x plus 1 by x minus 2. And when I do this, I also multiply the numerator by x minus 2. Okay? And for the second fraction, I multiply the denominator by x plus 1. And I multiply the numerator by x plus 1. So then I can add these two together to get a x minus 2 plus b times x plus 1 over x plus 1 times x minus 2. Now, if we simplify the numerator, we can have a x plus bx minus 2a plus 1b equals x plus 1 times x minus 2. Now, so what can we do with this result? Since this result is equal to the sum of these two, right? And the sum of these two is equal to the rational expression we have at the beginning. So that means these two are equal. And when you compare these two, you see they have the same denominator. So that means x minus 8 must be equal to ax plus bx minus 2a plus b. Okay, so this means what? That means ax plus bx must be equal to 1x. And minus 2a plus b must be equal to negative 8. So if ax plus bx equals 1x, that means a plus b equals 1. And negative 2a plus b must be equal to negative 8. So the question turns into a question where we want to solve a system of equations, right? Now, after we solve this system of equations, you will see a equals 3 and b equals negative 2. So therefore, we can, when we use a partial fraction to rewrite this expression, x minus 8 over x plus 1 times x minus 2 is equal to 3 over x plus 1 and plus negative 2 over x minus 2. So to find this integral is equivalent to find is equivalent to find these two integrals. Alright? Okay, now let me show you a different way we can use to solve A and B. Let's see. So if we compare this numerator with this numerator, you have A times x minus 2 plus B times x plus 1. This equals x minus B, right? So now I'm showing you a different way, a way we don't use a system of equations to find AB. So if we compare these two sides and think about if we let x be 2, so why do I want to let x be 2? Because if x is equal to 2, this part will be 0, right? So this part will be 0. So if x equals 2, on the left hand side we have a times 2 minus 2 plus b times 2 plus 1 equals 2 minus 8. So this is 0. Then we have 3b equals negative 6. So b equals negative 2, right? So we found b, right? Now, the second time, when you are looking for a, you want this to be 0, right? If you want this to be 0, which x shall we use? We should use negative 1, right? So if x equals negative 1, then we have a times negative 1 minus 2 plus b times negative 1 plus 1. And this equals negative 1 minus 8. So now this becomes 0. So we have negative 3a equals negative 9. So a equals positive 3.